Well, good morning or good afternoon, depending on where you are. Before we get started, just wanted to tell those of you who are here a little bit about CFTA. So CFTA is short for Campus FM Technology Association. My organization's been working with them for over 20 years. And when we started 20 years ago, it was a group of people at colleges and universities that were trying to figure out how to link CAD drawings and GIS data and disparate data sets together. Been an interesting group to work with. If you're not part of them, there's a lot of benefits of being part of the organization. They have an annual conference that I've been going off and on to for about 15 years now. They've got a portal where they're setting up knowledge for universities and colleges to share information, and they've got an excellent listserv. So if you're not part of our community, we'd invite you to come take a look. Sponsorship is, imagine it, we get a webinar, and my comment was no. I presented to a lot of you before, and I'll probably present again. I talk a lot about technology that Autodesk has. BIM has a lot of faces, and I said, why don't we do a series? So this is the first in a three-part series where we've got some peers. So you're going to hear from three educational institutions today that took very different approaches to BIM and how they were able to leverage that. We're also going to hear from industry experts. I'll serve as kind of a panelist as we go through this. One of the firms that we actually compete with in the Autodesk world, CAD Micro, TJ Mean from there is going to present in the third session as we start to talk about different ways to approach things. We look at this, we wanted to give you unique perspectives coming from different places to take a look and see how you could move things forward. So from a guest speaker's perspective, we've got four different people involved. So myself first, Peter Costanza with Imagine It. In FMP, I've been working with organizations trying to help them manage their space and asset and facilities type data for over 15 years. Today, we're going to hear mainly from our university peer partners. First, Amy's going to speak. I love what Amy's done. Amy is a registered architect, and she's going to talk about how her organizations leverage BIM in some architecture and construction, and there's some elements of what they're doing which makes them kind of unique. Then Devon Miller is going to come and talk, and Devon's got a completely different view on BIM. So Devon has a technical background and works in the commissioning department there at the university, and he spent a lot of focus on getting good data about assets during the commissioning process into the systems so the university could realize more of a bang on its buck. And as we talk about the BIM lifecycle, one of the big problems is getting that data during that commissioning process. And then the third person speaking is Joe Porostosky with OSU, who I've had the pleasure of presenting with a bunch of times. Joe converted most of the OSU campus from CAD to BIM, and one of the cool things is he used students, so there were some real cost savings. The other thing that I think is interesting about working with Joe, watching what he's doing, and personally, Joe's also got a master's in administration, and he's also got a master's in divinity. And I kind of tease him that he's been able to take BIM far within OSU, both because with that first master's, he knows how to communicate. And if I can make a joke in this current politically correct world, prayer kind of helps because BIM's a hard thing to do. We've all heard of all sorts of planning benefits of BIM, right? So we can understand spatial requirements. Feel and flow are really important. We're looking at things you could do with 3D and VR to get an idea for what a new site might look like. There are all sorts of design benefits that the AEC firms that are working with you are realizing more than you are, where they're able to build better, faster, smarter as they go along in their process. As you move along, BIM is being used extremely heavily right now in construction. Two main things. It's compressed the time in which buildings are done, and through the way you can look at data, you can do clash detection and make sure that things work before you go out into the field. And then there is what I consider the holy grail of BIM for owner institutions like universities or campuses where you don't intend to flip your assets is if you can get good data about your facilities into your facility management systems, you can help better manage those over time. One of the things I want to talk about, though, is looking at the future. So a lot of you are probably still working in a CAD world. If you're working in a BIM world, you're only doing it partially. And I know this because this is what I do for a living. And then the other thing is you look at it, BIM is kind of like a living entity if you think about it, right? It's a living, breathing thing where your buildings are getting changed over time. It becomes extremely powerful from a roadmap perspective as you start to look and smart campuses and digital twins become more important because BIM gives you that kind of base. Within that, we can then start taking a look at other areas like point clouds and digital pictures and how information like that might happen. So we can link point cloud data back to room data or asset data within that building information model. There are going to be a whole host of sensors that we're going to be able to put all over the place. And one of the biggest use cases for sensors are people like colleges and universities who have campuses with equipment sitting up on the roof. Wouldn't it be wicked cool if you could get a check engine light on those and know if there was a problem before something broke or someone realized something was running on a PM? The nice thing about IoT is you've got the network set up to set this up because you walk in a facility, you get internet access. So you don't need to lay any cable to do anything like that. Also, we need to look at the concept of, hey, we're a campus and we've got this BIM information, about this building, right? And we're starting to look at that in a context within mapping perspective from how do I get from point A to point B? How does the campus interact? Wayfinding and different things like that. Kind of see that there's integration X, Y, and Z coming. And over time, there are going to be more and more capabilities to help people better manage their facilities. And I'm really excited about some of the future things. So if I can give Autodesk a small plug here, Autodesk announced a product called Tandem that deals with digital twin data. And what really excites me about it is Autodesk design companies, you'd have design software. And when you look at how Tandem set up more from an owner's perspective to make sure, hey, in that digital twin process, as we go through construction, how do we get good data? So that being said, I am going to hand it off to our first panelist, Amy from the University of Wisconsin.
Good afternoon. My name is Amy Zabel U, and for the last 9 years, I've been working as the architect, engineer, supervisor for the Physical Plant Architect and Engineer Group, or AE Group for short. As Peter mentioned, I'm also a licensed architect with 25 years of experience. The AE group that I am with is responsible for the design of the remodeling projects on campus up to $185,000 construction cost. Any projects that are larger than that have to go through the state process. These projects are constructed by our in-house trade. So in some aspects, we're kind of like a design build firm on campus. Currently, our AE group has 14 full-time employees, and they consist of architects, mechanical designers, electrical designers, interior designers, and we have a CAD department with part-time students. So to give you an idea of the size of the campus that we're working on, campus itself has 20 million square foot total, housed in over 400 buildings on the immediate campus. And we work in about 13.2 million square feet of that. Looking at the map, the buildings that are colored in green are the buildings that we work in for the most part. The ones that are in red are athletics and housing, and they have their own facilities group. So overall, we do an average of 300 projects per year. So our BIM journey started around 2014. And at that time, we had developed the following goals. First was to implement Revit as a design tool and retire AutoCAD, effectively moving our design initiative to 3D. With this goal came the challenge of training staff in Revit that had only had experience in AutoCAD thus far. Our next goal was to develop BIM models of our existing buildings. The first step was to determine the level of detail that we would put into these models initially. The next step was to develop a way to continually do multiple remodeling projects in a Revit model and display existing and future conditions at the same time. And finally, we'd like to integrate the silos of data across facilities planning and management and make data accessible to those outside of each individual department. And lastly, we'd like to create a BIM standard for the capital projects. Even though the remodeling group doesn't work on the capital projects, that's another group on campus. But ultimately, we are the users of the BIM models that come from those projects. And so we would like to have a say in how we get the data for use in future remodeling. Along the way, we have realized many benefits from the BIM initiative that we have done so far. A large one is visualization. Being able to create interior renderings for client presentations has added great value and really helps the client with understanding spatial relationships, which is often very difficult to do in 2D, particularly with regards to furniture layouts and options and office suites layouts, even lab spaces. This has resulted in less misunderstandings of the final product, and clients know what they're getting at the end. Another huge benefit has been improved coordination within the disciplines. The ability to cut a section anywhere in the model and create as many as you need allows for great coordination of systems in tight places, particularly ceilings. Conflicts become immediately apparent, and the fact that you can update the location of an element, such as a door, in plan, and then it automatically updates an elevation and section, eliminates many potential for errors in construction plans and ultimately in construction. Our department invested in a 3D laser scanner, and that has been a tremendous time saver in populating models with mechanical, electrical, and plumbing systems. The fact that the scan itself is measurable allows the team to get accurate measurements and reduces and often eliminates multiple trips back to the site for field verification. Overall, the team has a much better work experience in the BIM world and prefers working in Revit as opposed to AutoCAD, which is a huge accomplishment as the move to Revit was met with resistance for the first few years. So that brings us to where we are today. Over the last 6 years, particularly in the first couple of years, we modeled 158 existing buildings, and now 99% of our projects are done in Revit. Occasionally, we'll do a project in AutoCAD if the scope is simple and we don't have a Revit model for the building. However, we are to the point where we have realized the benefits that on a recent project, we had a small single-story building that was off campus and we don't do much work in. And we didn't have much in the way of existing information. We had some basic AutoCAD floor plans and PDFs of the mechanical electrical system. But the team decided that it was worth the effort to model the building in Revit to enable coordination in a tight gable roof condition, and we had to put a mechanical unit on a sloped roof, and having it in 3D saved a lot of time to work out the conflicts. We continue to populate our models with the mechanical, electrical, and plumbing systems with various methods. One is building families with BIM-ready parameters to get the information that we need. And then, as I mentioned before, the 3D laser scanning has been a tremendous time saver. Now the entire staff works in Revit and is required to learn it if they don't know it when they're hired. As I mentioned before, interior renderings have been very beneficial for clients, and we're continuing to populate the existing information in the models as we go. In particular, like life safety information, we can identify firewalls. We are adding plumbing fixtures to the models, and of course, we're always adding more mechanical, electrical, and plumbing systems as we go. So in conclusion, we have come a long way and have built a firm BIM foundation that we continue to build on, and it continues to evolve as we gain more experience and more information. So our BIM journey continues. And with that, I will hand it over to Devon.
Hello, everyone. Hope everybody's doing well. As Amy mentioned, my name is Devon Miller, and I'm the building commissioning specialist for Western Michigan University. I work in facilities management in our engineering division. I have 7 years experience here. I've been here 7 years, Western. I have over 15 years of experience in project management relating to energy conservation, building automation systems, and building commissioning professional through ASHRAE, and I'm a lead accredited professional through GBCI. So, our BIM initiative kind of goes back to around 2010. So at that time, one of our main goals was to make information more accessible. And what do I mean by that? Basically, like I said, we were kind of getting to a point where we wanted to kind of have a visualization of our buildings on campus. So around 2010, we start looking at how do we go about modeling all of our buildings on campus, so that we can possibly add information to those models down the road. So at that point in time, that's when we start working with Autodesk, and with our at that point with our Autodesk reseller, Cal Blue, kind of helped us develop that initial thing of modeling a building on campus. The other thing we wanted to do was improve the audit process to reduce errors and discrepancies. So what do I mean by that? So prior to BIM initiative, we had our CMMS that we didn't really update it as frequently. So this process kind of helped us go through and make sure that everything in our CMMS was accurate. Relied us to go out in the field, verify that the equipment that was out in the field, the model numbers, serial numbers, all that information was accurate in our CMMS. So that allowed us to do kind of an audit process with this BIM initiative to make sure that as we start doing these models, that any information that we put into our Revit models is accurate within our CMMS. The other goal was to improve the handover to operations. So like many of you, before the BIM initiative, we had documents all over the place. If our trades had a work order, the time for them to process that work order just took a lot of time, because work order would come in and then they would have to go and find the information that they needed to do necessary repairs. And so this process allowed us to, one of the things we wanted to do is bring all that information to one source, which in this case would be into the Revit model. And then the other thing was we wanted to kind of streamline the change management. So what do I mean by that? So biggest thing is like many of you, we have a number of renovations that take place from a small project to a large project. So one of the things we wanted to do is kind of be able to make that change in one location, or so we don't have to update so many different databases. This process helped us kind of streamline that. So now that, when a renovation is done, we can simply, update, our simple floor plans as well as the BIM model, so that that information matched. So that, what was on our simple floor plans from a square foot standpoint matched the square foot in our Revit models. So the benefits of our BIM process. One of the things we want to do is modernize the application for assessment information. Like I said, we wanted to basically leverage our campus Wi-Fi and our CMMS that was already in place. So basically now we wanted to make sure that when our trades go out to service a piece of equipment, that they can easily pull all that information up necessary on their iPad. We started this process in 2010, but our trades didn't start using iPads until 2014. There was a time gap there between when they had their iPads in place, which gave us enough time to really truly understand that, hey, what do we want to put in these models? What information is critical to our trades? So that gave us that time to work those things out with our trades to find out what information is needed for them to be able to service a piece of equipment. So that's why we had that big delay between 2010 and 2014. They gave us the time necessary to really fully understand what is really important to us. And once we determine that, we can basically apply that to our big capital projects that we do in Revit. The other thing was reduction in wasted resource association with past process for assessment information. Like I mentioned before we did our BIM initiative, when a work order came in, it took our trades a lot of time to basically find the information they needed to make the necessary repairs to that particular asset. Now, when a work order comes in, they can pull up not only the information about their piece of equipment, but they also can pull up the information about where the issue resides. So they can pull up a floor plan on their iPad, they can pull up their Revit model on their iPad and basically get all that critical information that they need about that piece of equipment, from the model number to the serial number. We link the O&M manuals, pump curves, all that stuff is linked in our model. So they can basically use their finger and click on a piece of equipment and get all the necessary information before they even go to that particular building to service that piece of equipment. When we did this initiative, we had to basically go through and audit everything in our system, which I mentioned. We verified all the equipment out there in the field. We use students, so when we went through this process, we had students on staff that were trained to model the building. So one of the things they would do is they would go out in the field and they would locate where the piece of equipment was out in the field. This allows us to verify, the equipment that we're bringing in. So for our particular models, for our existing equipment, we focus mainly on mechanical pieces of equipment. Equipment that our trades touch on a routine basis from a preventive maintenance standpoint. So we're looking at chillers, air handlers, fans, pumps, and so forth. As our students were developing these models, they would go out into the field and not only verify the equipment information that was out in the field, but they would basically, sketch out where the piece of equipment was generally located in that particular area in the mechanical room. So that when they came back to start developing the models, they would basically, verify that the information of the equipment matched with the MMS, and now allow us to kind of make sure the information was accurate. From a simple floor plan standpoint, like I said, basically we use our simple floor plans to help develop our models. That's kind of the last bullet point about being linked. We basically they pull those in to help develop the models, and you can see the little screenshot there kind of shows the process that our students went through on developing the particular model for the buildings on campus. The one thing I will kind of note on these is our buildings, we just used a generic library. So when we went through, we just used the libraries to put together, our walls, our slabs, our doors. They basically just a blank room, doing a bit more time on the exterior. The whole idea is they want to make sure that the rendition or the model kind of matched what the building looked like. But like I said, they were very low level detail. We didn't spend that too much time. And then as far as equipment goes, kind of pulled from the manufacturers. They had a model of a pump. We pulled those ends, and then in some occasions, the students spent extra time on actually customizing models of certain equipment, because we have equipment in our buildings that didn't have a model. So they kind of custom did those models to make the actual asset look like what it is out in the field. So a particular air handler kind of custom did it and put it in the model so that for our trays, it kind of looked like the piece of equipment was actually out in the field. The last big thing was, now that we had these models with all this equipment, and the next big thing for us to kind of approach was to synchronize the two databases. So we kind of leveraged our CMMS system. We've been with our CMMS partner now since 1997. So one of the things we wanted to do was kind of leverage them to kind of help us develop a tool that will allow us to basically sync the information between Revit and our CMMS. So they kind of worked closely with Autodesk and came up with an interface tool that allows us now to push information from Revit into our CMMS or pull information from our CMMS into Revit. And that allows us to make sure that anytime a piece of equipment is changed out, it's easy to pull that information into the Revit model. The other big thing that's helped us do is, from the standpoint before our BIM initiative, we had to actually go out in the field. So anytime a new project was completed, someone had to go out in the field and record all the information about, that piece of equipment. They had to go out in the field and basically note all the model numbers, serial numbers, and all that information. Then they had to come back to the physical plant and hand enter all that information in. Now that information is streamlined. So now with a capital construction project, we get a level 500 model, and then we're able to sync that model with our CMMS and actually push all that information from the Revit model into our CMMS system with a click of a button. So all the model numbers, serial numbers, the O&Ms are linked in the model. So all that stuff now is pushed in, and it makes the process a lot easier and quicker. So where are we today? I mentioned where we're at today is all of our buildings on campus have been modeled. 138 of them, we have piece of equipment that are put in a model. And you can see here with this, where it says properties, those are kind of the property asset information that we have. for all the various pieces of equipment. So you can see that for this particular pump that's highlighted in blue, you can see what information our trades can get. They know what the GPM of that pump is. They know when that pump was installed. They know who the installer was. We give them the make, we give them the model, the O&M, pump curve, sequence of operation are linked. They get the serial number, and they get the actual asset ID. So every single piece of equipment has a unique ID associated with it, and then they know what the warranty is of that particular piece of equipment. So right now we have about 8.8 million square feet that is modeled on campus. Our initial model, we use 6 students. You can see the budget information, around $60,000 budget, 7,050 man hours, and we were able to do that roughly in 13 months. That's just for the initial modeling the campus. That doesn't take into consideration the extra time it took us to put the equipment and everything into our buildings. Other things we're doing right now is we're actually in the transition process. So one of the things we were doing, our trades were able to get the models with glue. Right now, we're kind of transitioning to another viewing software called Deluxe FM. So that's kind of what we're doing right now. We're kind of, making a transition to that platform currently, which has been put on hold with COVID, but that's another platform that we're kind of using because they have a ability to allow us to bring in GIS information. So maybe when we get out of this COVID thing, that will kind of restart back up. The other big thing that we're trying to streamline is the change of equipment process. So like I said, it's not automated. When a piece of equipment is changed out, we still have to be, know when that piece of equipment is changed out so that our PM scheduler can basically push that information from our CMS into the Revit model. So that process is still not automated per se. And we still have to be notified when a piece of equipment has been changed. So that's kind of where we are today. So now let me turn it over to Joe.
Hi, everyone. My name is Joe Porstowski, and I am the Director of Facilities Information and Technology Services at The Ohio State University. And I've been here for 12 years. Just to give you a little overview of the department, just to give you a sense of the kinds of things that we're working on, we have 3 major areas: architectural services, which really handles all of our BIM initiatives, which I'll be talking about here in a second, managing our building models, and we still have a little AutoCAD that we're still working on. It also handles room numbering. Those are the main items. Obviously, they've got a number of other little things that they do. GIS services handles all of our campus mapping, the base map for our campus, and the application development. We got a number of applications that we have developed in-house and use, campus addressing, and do a lot of custom mapping and data analysis. And lastly, data services, all the space data, how our space is being used, square footages, lots of reporting, a lot of data analysis, and all of our record document archiving. So that's our group in a nutshell. From a BIM perspective, we've been working on what we call our Buckeye BIM initiative for around 10 years, since about 2010, although we started looking into what BIM meant and what Revit is a couple years before that. We didn't get serious until 2010. And we started off with our BIM for existing buildings part of our project, and that was to convert 37 million square foot of existing AutoCAD into Revit. Now, it wasn't 37 million at the time. We obviously have grown since then, but as of today, that's where we're headed towards. Then we also, after a number of years of doing that, we moved into BIM for design and construction, where we require BIM to be used on large projects, specifically over $4 million. And then lastly, we're moving into BIM for operations. How do we use BIM to support all of our operational work? And we think about that in the continuum of build, maintain, integrate, and operate. Build is building our existing facilities. Maintaining is how do we maintain those models over time. Just as Peter mentioned, that BIM is a living entity. It's always changing. That's the way it is for us too, obviously. And those models that we have, our buildings need to be continually maintained. Then integrating data we get from the design and construction process, and how do we use that then as we get into BIM for operations. Some of the benefits we've seen specifically for BIM for existing facilities and transitioning those AutoCAD to Revit models is that we eliminate the out-of-date plans and improve our accuracy. Devon mentioned this a little bit actually too, is this the ability to go out and look at our space and really do a very deep dive to ensure that we've got it right. We did the best job we could maintaining our AutoCAD, but you know, we didn't go into a single building as we converted these and not find something that we had missed. And so we were able to improve the accuracy of our existing plans, also including lots of great 3D data, things like window location and size, roofs, ceilings, heights of buildings, all sorts of data that you're not going to get in a 2D AutoCAD drawing. And that's been very helpful as we think about how we plan our facilities, having that additional data available to us. From an effort perspective, we feel that updating Revit is actually a little quicker than updating AutoCAD in a number of ways. Now, I will say that there are other challenges to using Revit behind the scenes as far as management that can sometimes offset some of that. We worked really hard to standardize our models and implement as much automation as we can so that those types of challenges don't really outweigh things. But from the day-to-day perspective, following a renovation, updating those models is actually a little quicker. Our models are intelligent, compared to AutoCAD, which really is just lines on a digital piece of paper. Revit understands what a room is, what a wall is, what a plumbing fixture is. There's a lot more we can do with the Revit model because it's intelligent. It understands what it is. And then also it's a foundation for other data sets. We are only building basic AutoCAD or architectural models. Just as Devon mentioned, we really kind of stuck to very generic components for a lot of our models. It's not going to get really detailed in a lot of areas. It's more representational. But the beauty of that is that we can use that as a foundation for anything else we want to do. For example, in the image here, this is an image from an MEP model that the College of Engineering is maintaining for one of its buildings. So they've been able to take our architectural models and then build on top of that. And they use a 3D laser scanner, just as Amy was mentioning too, to model all their MEP. And so they've been working on that for a number of years, but they've been able to build right off of our architectural models and bring extra value to our models. In addition, we've seen a lot of benefit through being able to communicate. And Amy mentioned this also, the idea that you can be able to show somebody a furniture layout really easily. It's very low-hanging fruit. It's simple. If you've got a model, putting that furniture in there is pretty easy. We actually have a student-led design studio that does a lot of this work. Maybe before we even have the funds to do a lot of work, say within a particular department, the design studio, the student-led design studio can start playing around with ideas and concepts and use that as a way to determine whether something makes sense to advance. In addition, we've been able to do things like on the left side where we have a good amount of interior and exterior information available now. And that glass facade you see there doesn't exist today, but it was kind of an idea, a concept that we wanted to play around with. And being able to play around that internally without spending any cash on consultants has really been a big benefit to us. Being able to help visualize these ideas three-dimensionally, where two-dimensional drawings are just hard for a lot of people to understand, to be able to see that future. Three-dimensional drawings really bring it to light. Our standard, our BIM delivery standard, where we require BIM deliverables for our larger projects, has really improved the quality of the deliverables we get, because we're putting a lot of guardrails around what we want to see. But also it improves the data, and Devon mentioned this too, getting data out of these projects. You have all this rich data that you're gaining during the design and construction process. And then previously, you're going out there and having to collect it all by hand. Now we're able to get all that information through the design and construction process and very quickly get it loaded into our CMMS. And so it's much closer to day one that we can have data available and begin to use it. So where we are today, about 91.5% complete with converting our campus, which means right now we have 478 buildings in Revit, a little under 34 million square feet. This actually includes not just our CAD to BIM efforts, but as we get those models from the design and construction process, that's included in that too. Now we've actually modeled more than this already, but we've had a number of demolitions of buildings or leases that have expired. But our goal is to get to 37 million square feet. I think this last 8% is going to take us a little while. We're getting into agricultural type locations, a lot of smaller places. lot of smaller buildings that take longer per square foot, and are also they're much further away from our central campus. And this past year, we really haven't been able to hire our normal summer students due to COVID. So that's put a little bit of a pause on our project, or continuing the project right now. And as I mentioned, we are required to use the BIM standard on all projects over $4 million since 2015. We actually recently have developed some ways of using the standard for projects under $4 million. We see a lot more of our internal PMs wanting to use the standard for smaller projects. And so during the RFP process, they can make some changes that would require that, but it's more like a BIM light. So we take out some of the requirements that a project over 4 million would have to use. And we're always continually improving that BIM PDS. Every year, typically we come out with a revision to it as we learn new things about what works for us and even what works for our design partners and our construction partners. And we're always improving that data handover process. And that was one of the more painful parts. We didn't know what we were doing initially and had to learn a lot about how to get the data out of the models to the contractor and to us in a way that's not overly burdensome. And we're still continuing to make those improvements. We've got a lot of improvements kind of coming up over the next year that should make that process even smoother. So where we're headed, we really want to get to this idea of really a connected BIM for the university. I'll say that when you compare us to where Western Michigan is at, they've made a lot more progress in this area of using it in operations than we have. We definitely have a ways to go. But our goal is to get there too, to have really a rich data environment in which a lot of our data is connected through a central, say, BIM middleware, where we have space data and asset data and work order data and sensor data all available in tablet in the field. We're also looking at BIM 360 and how we might use it internally and looking at how it helps us to collaborate within our own teams, but then also with other teams across the university that manage their own models. And we're also looking at how BIM 360 might adjust the way that we have projects delivered to us too. What would it look like if we started using 360 or required it to be used or purchased it to be used on projects? We're not really sure how that's all going to work out, but we're really doing a deep dive into the potential benefits and what this might look like for us as a university to use to improve collaboration, to improve data handover, to improve some better decision making throughout our design and construction process.